So our next presentation was going to be given by Alex Kanelakos. Instead, Ike Therio will be giving his talk, and the talk is on NASA flight operations in the Artemis world of EVA tools.
Okay, thanks, Jose. Good afternoon. My name is Ike Therio. I'm filling in for Alex today. Great to see a lot of familiar names and faces, and thanks for giving us some time to speak today. Next slide, please. So NASA Flight Operations Directorate, or FOD, is where our astronauts are located organizationally, along with flight controllers and instructors for NASA human spaceflight. So looking at the second half of this first bullet, the overall planning, directing, managing, etc., we often summarize that as plan, train, and fly. The second bullet, in other words, FOD has overall mission authority whenever our astronauts are flying. So we have ultimate responsibility to keep the crew safe and successfully complete mission objectives. These last two bullets all summarize just as FOD often serves as the lead integrator across many disciplines and vendors and stakeholders. We compile all the priorities and constraints and analysis, and we turn that into a mission plan, and then we control the mission during execution to make sure it's completed successfully. So therefore, we often find ourselves in conversation with many individuals across orgs, both inside and outside the agency, and integrating all of this to have a successful mission. Next slide, please. So something we sometimes say to each other is that EVAs are like running a marathon while taking the SAT. So there's a very high physical and very high mental demand for each minute that you're under the clock. And I say that here, in other words, everything we ask our crew to do ought to be as easy and natural as possible in order to enable the efficiency and success of the mission. And like Dean said earlier, every minute is precious. There's not many other things that we do in human spaceflight that is as risky as EVAs. And the crew members are ultimately responsible for the mission success and their role in their own survival. Skipping down to this fourth bullet, Artemis EVAs will not be a walk in the park. So we're sending our crew members for Artemis to the harshest and most dangerous places crew members have ever been. Alex says just crew members, but I think we could even say anyone at any point in time. Skipping to this last bullet, in order to keep crew alive, EVAs as efficient and effective as possible, hardware must be designed with EVA operations in mind. So in other words, this hardware has to be designed with the operator in mind from the beginning of the design process. Next slide, please. Okay, so anyone who's worked in a pressure suit could probably tell you that you can't take any task for granted. You have to think through most of the things that you do before you do them. Or at the very least trained enough to where you don't have to think about it. Also, you have to be able to demonstrate that you can perform these tasks before you go out on your mission, or at the very least, it's a really good idea to do that. So what makes EVAs difficult and also risky? For limited mobility, flexibility, being in a pressure suit constrains what you can do. Often people bring up the gloves as the most constraining because you use your hands quite a lot. And if you want a sense of what that is like, and if you haven't done it, if you have a pair of ski gloves, it's often a good analog. Just try going about your daily life wearing those ski gloves and trying to do all the things that you would normally do. Also, the greater mass, the mass moment of inertia that you have to handle, different CG and a different gravity field, that brings its own series of challenges for crew members just getting around on the surface. The greater volume. So we experience this a lot with our ISS crew members in the EMU currently. Your suit envelope, it's hard to know exactly where your suit starts and stops all around you. So bumping into things and not being fully aware of your envelope at all times is fairly common. And then also the environment. And here I just want to touch on the extreme lighting conditions. So the lighting alone will have huge operational impacts to everything from navigation and safety to sample collection and storage and return. The lighting is, I think, going to be one of our biggest challenges going to the South Pole. So in FOD, we have a lot of in-house experience working in pressure suits, not only from our astronauts, but also our flight controllers and instructors. We also have the opportunity to get in there and do some work. We have a lot of institutional knowledge, and we have people like suit technicians who work on suits day in and day out to support testing and training. Next slide, please. Okay, so I just wanted to provide a few examples that we've seen here in flight ops of good design, bad design, and well, ugly but doable designs. In the good category, I think of these items as things that have stood the test of time, rarely receive any negative feedback from end users. For ISS, this top left picture is called a crew hook. These things have been cycled thousands and thousands of times with very, very low failure rates. These things are generally just simple tools, do their job well. Hand tools on Apollo also receive very few negative marks, save for any rotating mechanisms that could bind up. The bad, here in the middle, things in this category, I think of, they were designed with best intentions in mind, but either kept the end user out of the loop until very late in the design process, or failed to function as advertised, and caused significant problems and delays during the mission. For ISS, we have this device here at the top called the Terra, which was designed for crew to capture and stow large boxes on structure. However, the structural interface is only about 4 inches long, and it's hidden once you install anything on top of it. So therein lies a large problem, right? Shown at the bottom is the MET, and like Dean mentioned in the chat earlier, the jury's still out whether or not the MET was just bad design or bad ID in general. And then in the ugly category, these things mostly work as advertised, but require a lot of overhead, often a topic of a lot of negative feedback from crew members, or things that if steps were performed incorrectly or a small component fails, it can have a huge negative impact on the mission. For ISS, fluid QDs are notorious for leaking due to just one of the many seals that in these devices, and it was installed backwards. And so we get these leaks, we get pressure buildups, and then they lock up and you can't open them. For Apollo, the example that we came up with was the ALSEP. It had to be leveled on the surface, and we had at least one instance of these leveling blocks just falling off and making it much more difficult to get that thing level on the surface. Also, these cables that got strung out from a central node, crew members tended to trip on them, and there's at least one instance of those breaking during a mission, and we have to spend time and effort to go and repair that in the middle of the mission. Next slide, please. Okay, so all of this to say, really, if you find yourself on a team and you're designing experiment tools, really any hardware that's meant to be used by astronauts, please get flight ops involved in the design process as early as possible. On the last slide, just wanted to show a few examples, but there are many more examples of tools and equipment that have flown that could have been much better if we kept the end user in mind from the very beginning. Really, once you establish that some widget needs to be built and we stake out requirements, we ought to focus on optimizing its use in the field. For which there are a couple of considerations I listed here on the right side of the screen that can help in that process. Some other considerations that are important that are not included include stowage and launch configuration and overall mass and preparation and deployment overhead and timeline development and crew training and mock-up development. And there's so many other things that go into having a successful flight piece of hardware. And that's where we can really help develop and fill in those gaps. And that's all I have for you today. If you have any questions, please just throw them in the chat. And Jose, back to you.